Okay, yeah, awesome. Okay, so hello, welcome to week 4 of this lovely class. Today we're going to be talking a lot about manufacturing processes, and then we're going to even do a demo today. Uh, I was lucky enough to get my printer up and running for our class meeting today, so we have a nice printer running, and then I'll do a demo later. I forgot to bring more demo prints, but yeah, you guys can take the one that it's making right now and the other one that I'll do later. But yeah, okay. So I talked about this a little bit like at the end of last class, but we do have a final project in this class. Again, it's not something that you should be super concerned about because our goal is to give you all the tools to be able to do this pretty easily. So again, you're going to be creating a CAD model from scratch, which you're all familiar with. Please don't do the engineering fountain or like the plane or any of the previous assignments, which makes sense because you're going to do it from scratch. We want you to have 5 design features. So if you want to do like 5 different extrudes, that works. But I would prefer you mix it up a little bit. Again, this class is very much a you get in like or you get out of this class what you put in, right? So if you work hard and you want to push yourself to make a really cool model, then you'll learn a lot along the way. Or you can just be lazy and then turn something in that is technically correct, and that's fine too. But again, it's totally up to you. And then the last point, we want your designs to be designed with manufacturability in mind. This is kind of like a very vague, like grading thing. But the reason why I'm putting that there is because we will give you the option to 3D print your final projects. And if you give me something that I can't 3D print, then I'm not going to 3D print it. And then I'll be sad that I can't give it to you. And then you'll be sad because you don't have your final project, right? I would love to give everyone something like a little piece of like something they've done in this class just to like put on your desk or something. And yeah, it'll probably be printed on that printer right there. So yeah, please make something that I can actually print. If not, then I probably won't print it or I'll talk to you about it. Your final projects will be due like the week after week 5. So it's like assigned now, but you have a week from the quote unquote end of the class to finish it. But yeah, obviously I haven't like done a ton of grading yet, so I'll get to that once my exams are over. Um, but yeah, it shouldn't be too bad. Again, I'll be here if you have questions. But yeah, let your mind run free and create cool stuff. Again, like these are some of the final projects from other semesters. These are some of the people who, spent some time on it and made something really cool. Again, there's no pressure to produce something exactly like this. But if you do, then we'll remember you and you might be on the slide next time. But yeah, so today we're going to be talking about that last point on your final project, right? You want to design with manufacturing in mind, right? So a lot of the things that we make or that you will design will probably be designed to be made in some fashion, right? And there's many ways you could go about doing that, right? One of the more traditional ways is called subtractive manufacturing. So it's when you take like some kind of material and then you'll remove that material with some kind of tool. And then in the end, you'll have your final product, right? So you'll take like this block and then this tool that probably spins really fast or some form of cutter will go in and remove the material. And then once it's finished, you have your final product, right? For our class, oh wait, sorry, I forgot about this slide. Yes, there are many different subtractive manufacturing processes. So the most familiar one is probably like a drill. But then when you get to more heavy industrial stuff, you'll get to milling and turning, along with like routing and grinding and stuff like that. So when you think of like a workshop and making things, it's oftentimes subtractive manufacturing. However, there's something else. So we have additive manufacturing, and it's becoming a little bit more popular these days because the technology is improving and it's getting cheaper. But basically, the concept instead of taking away material, you're adding it, right? Add, subtract, math. So in this case, it has like a nozzle that deposits material onto some kind of plate, and then it'll build up your model into a finished product, right? And the idea of additive manufacturing, in my opinion, is great because there's a lot less waste involved uh, in theory, right? You're not cutting away material and you're just using the material that you need for your part, right? And then the other thing that it allows you to do is it allows you to create geometries that subtractive manufacturing can't, right? So you can have very complex lattice structures or organic looking shapes on your parts without much effort, right? A lot of the times to get a really complex shape, you'll need complex tooling or really expensive machines. But now we can get a nice 3D printer. It's relatively cheap compared to the other machines, and it can create a lot of awesome parts. So yeah, additive manufacturing, a lot of people think about 3D printing when you hear that word, but injection molding is actually also a form of additive manufacturing. It's a very popular manufacturing method for high volume parts. But yeah, we're mostly going to be talking about 3D printing in our case, just because that's what I'm going to be using to create your final projects if you want those printed. So there's a bunch of applications to additive manufacturing or 3D printing. Most commonly, people refer it as like a rapid prototyping tool. Again, this is because you don't need any advanced tooling or jigs to create complex structures. And you can just press print, and this printer will just make it. Oh, wow, it finished already. Cool. But yeah, it's actually used in a lot of other places that you may not think. Um, there are some automotive parts that are starting to be 3D printed. Obviously, not all of them, but there's some small 3D printed or additive manufacturing parts in certain assembly lines. I think Ford does some of that stuff. And then there's some cool like hypercar called like C Zinger, and that they're things like fully 3D printed. But yeah, aerospace is another great example of additive manufacturing, again, because you can create very complex shapes, which also allows you to reduce weight and stuff like that. I know Porsche, I guess is going back to automotive, but Porsche in some of their high performance vehicles, they use 3D printed pistons because the inside is actually hollow. So it makes it lighter, and then it allows them to get higher RPMs and more power and stuff like that. Um, People are also experimenting with like 3D printed houses, and then other fun stuff like clothing and jewelry and just like art stuff. But yeah, again, there's multiple types of additive manufacturing processes. There's selective laser sintering, which is basically taking a big bed of powder and then using a laser to like melt selected pieces or selected areas of powder over and over again until you get your fully 3D printed part. It uses the powder around it as like a support material, which is really nice. And then you can reuse that powder later, right? SLA printing is also kind of coming on the rise, and it's basically a resin-based printing system where it shines a UV light, which cures the resin like an epoxy, and then it just goes up and up layer by layer until you get your finished part, right? But most oftentimes when people like us refer to 3D printing, we mostly are talking about FDM or FFF laser 3D printing. And this is because it's just kind of the most widely available one. It's the one that you hear about the most. And it's gotten cheaper over the years. Like you can get a 3D printer for like 150 bucks, which is kind of awesome. When I first started getting printers, they were like 3 or 4 times that price. So yeah, it's getting to be like very like achievable for like broke college students like us to buy printers and then have a lot of fun and create a lot of things. The principle of FDM 3D printing is basically like a really advanced hot glue gun, right? So everyone knows and hopefully has used a hot glue gun, right? You know how it works. So if there's a nozzle on the tip that you shouldn't touch, and it gets really hot, and then you force a hot glue stick through the nozzle, and then it like deposits the glue, right? For 3D printing, it's basically the same thing, but instead of glue, you're using some form of plastic or other material, and then you're mounting that nozzle onto a carriage, right? So in our case, this carriage moves in 3 different directions, X, Y, and Z, to create 3D printed parts. But there's also other things. They have like more than 3 axes. Pretty cool. But the principle is basically a hot glue gun, just forcing material out a hot nozzle, and then just doing it in a very precise manner to get the desired part that you want. There's a lot of different things that come into 3D printing. There's a bunch of different settings that you'll see in a little bit. But if you think about like your normal like paper 2D printer, there's a couple things you can change, right? You can change like the margins, and then you can change like the DPI. But for a 3D printer, because you're going in 3 dimensions, there are a bunch of other variables to consider, right? So the first one is layer height. So the layer height is basically how high the nozzle is from the previous layer, right? So if you have a taller layer height, you'll be printing less layers, and it will increase your time just because the 3D printer doesn't have to move as much, but you'll lose some resolution, right? So if you look at like the top left, it has like a 0.8 millimeter layer height. I don't know if you can see it, but if you look closely, you can see the lines in the print, right? And it's because the distance is so tall that you can see it, right? But as you can go farther down on the right, the layers get more and more fine. So those layers become very small, and it becomes a little bit harder to notice, right? So if you're going for really high detail prints, you usually want a really small layer height, but in general, that sacrifices time because the more layers you have, the more time it takes to print. If you didn't know, basically how the 3D printer works is it basically draws a 2D profile of your 3D printed part, and then it moves up a little bit and then does it again, right? And then I'll show you how to use the slicer in a little bit, but it'll make sense as we go out or as we go on. Perimeters are also like an important thing, especially when you're designing things for strength. The perimeter count is basically how many walls or how many times the nozzle will move around the edge. So the more times it does it, the thicker the outer shell will be and the stronger your part will be. But again, if you add more material, if you add more paths for the printer to follow, it increases your time and material costs. But again, this all depends on your use case, which is also why 3D printing is awesome, because you can tune these things specifically for your needs so you get the material properties and strength properties that you're looking for while staying like economical and stuff like that. Infill is also something that is pretty important. Infill is basically how hollow your part is. So if you didn't know, a lot of 3D printed parts, I would say a majority of them are somewhat hollow on the inside, right? And this helps save time and material, and it makes your parts lighter. Believe it or not, most of the stuff or most of the material in the center is actually not needed when it comes to strength. Like if you're going for ultimate strength, yes, you want it to be like 100%. But for a lot of use cases, people run anywhere from like 15 to like 25% infill, right? So you actually don't really need that much to get the properties you desire. And the less infill you use, the faster it prints. right? But again, it's balancing like speed and stuff with strength. So you want to keep that in mind when 3D printing stuff. Supports are also something that you will encounter with FDM 3D printing. It basically just is a limitation with gravity, right? So you can't really print things in midair unless your printer is like extremely well tuned, and most printers unfortunately aren't. So if you see in this model on the bottom, it has like this thing that kind of sticks out the side, and you know, it prints layer by layer. So if it was to print that sideways cylinder, it would just print in midair, and then it would droop, and then it would be sad. It won't be dimensionally accurate, and then your print will just be ugly, and you'll be unhappy. So what we use are supports, right? So supports is basically a sacrificial material that your printer will build up and just kind of act as like a little bed to support the material, hence why it's called supports. And then in the end, once you take the part off, you just remove the supports and you have your finished part, right? Again, we'll be talking about this a little bit later, but we want to try to limit the amount of supports just because it adds time, it adds extra material, and it adds post-processing time, right? So if you design something in a way that doesn't need a support material, you can just take it off the printer and then use it, right? But if you have supports, then you need to take the time, get some pliers, kind of rip it off, maybe even sand it if the surface isn't nice. So as designers, it is up to you to design good parts for manufacturing, right? And in this case, you want to think about these things like limiting supports when designing 3D printed parts. So yeah, here's a good example of supports. Again, it's not always like avoidable. Like an H is just an H, right? It's totally flat along the top. So you might need a support there. But again, if you're designing something and you can avoid it, you could probably design the support out. Okay, so now we're going to be doing one of the assignments for today. It's actually the only assignment for today. But we're going to be downloading Prusa Slicer, which is a slicer that you use to program the 3D printers. And then we're going to slice a benchy real quick. Unfortunately, it's not letting me like throw in the installers into the Discord, so we're going to have to download it off the website. So yeah. If you go under the resources tab, I have this link here, and if you click on it, it'll open Prusa's website. You want to click on like the drivers and apps section to download it, and then it will download the installer, and then it'll let you install things. I already downloaded it. I forgot to uninstall it. So if you want to do that now, it'll just like run you through the wizard and stuff like that. And yeah. So I'm just gonna launch it. Is anyone having problems like downloading an installer? Sometimes that's a problem. Okay, awesome. Okay, so while that's downloading, I'll talk a little bit about what we're going to be doing with the slicer. So again, Prusa Slicer is one of many different programs you can use to slice a file for 3D printing. Just like Fusion, there's like a bunch of different programs that basically do the same thing. I prefer Prusa Slicer because I had a bunch of Prusa machines in the past, I'm moving away from that and trying other slicers, but they basically do the same thing, right? Basically, what the slicer will do is it'll take the model that you've created or downloaded off the internet, and then it will slice it into a bunch of like fine 2D profiles, right? And then what it will do is it'll generate a path for your printer to follow um, to create your part, right? It'll make more sense once we slice it and I can show you. But yeah, is anyone having trouble installing it? I think the install is I'll walk you guys through it. Um, so yeah, you'll be greeted with a welcome screen like this. I think if you press next, it'll ask you to like add a bunch of printers. For our case, if you want to scroll down and then choose the original Prusa Mini and make sure it's not the input shaper one, it'll just help me with grading because you're going to be slicing it and I'm going to make sure you did it right. And if you do it on the wrong printer, it'll give me the wrong time and then it's not right. So, yeah. Anyone having trouble finding it? Yeah. Choose the one on the right. Make sure it's not the input shaper one. Um, 'cause, yeah, it would just post a different one. Yeah. So if you exited out of the printer selection, um, over here on the right, there's this drop down that says printer. For me, it says like Mark III because I have a Mark III at home. But there's this little gear on the right side. So if you click on it, and then if you click add or remove presets, it'll take a second to load, but it'll give you all those printer options again. Choose the again. So when you go to select the printer, scroll down a little bit. Uh, in this area that says mini family, um, choose the one on the right and then choose the 0.4 millimeter nozzle. Yeah. Is anyone having trouble finding your printer? Okay, awesome. I'm gonna start another print. See if I can get another PDF. Okay. Is everyone good here? You found the printer? So, um, if you accidentally selected another printer in the checkbox, you might not have the right printer loaded into your slicer. So again, if you go under the printer category, I have a bunch of them because I've worked with a bunch of printers, but you should be looking for original Prusa Mini and Mini Plus, right? Make sure it doesn't have like an IS next to it or anywhere in it because that means it's the input shaper one. But yeah, if you click on it, it should load like a build plate that looks like this. If yours looks like bigger or doesn't say mini on it, do you want to raise your hand? I think that one looks wrong. I can't tell from here. Everyone get it? Is everyone good here? Yeah. Okay, awesome. Okay, so now that we've loaded into our uh, kind of profile, now we can start slicing stuff, right? But first, to slice something, we're going to need a model. So what we can do is we can find them on the internet or you can design it yourself. For our case, I'm going to be just doing a 3D Benchy. If you don't know what that is, it's kind of like the classic 3D printer test print. So what I'm going to do is I'm going to find it on the internet real quick, and then you guys can follow along. This is also just to show you that there's a bunch of models out there that you can use for free. So I'm just going to go into the browser, and then I'm going to go to this website called Thingiverse. There's a bunch of different repositories out there, but this is like one of the classic ones. I'm pretty sure the Benchy is on here. But if I type in Benchy, it's like bench, but with a Y at the end. It should pop up. Okay, maybe are these all like the weird ones? Okay. Okay, yeah. So you want to find the 3D Benchy. It should look like this. Um, it's made by like this person who calls himself Creative Tools. Yeah. Is everyone found that? I had to Google it, but if you type in 3D Benchy, it should pop up. But yeah, I'm gonna download it and I'm gonna send it out if you guys can't find it. But yeah, basically this print is a very classic 3D print that a lot of people use to test the different limitations of printers. So yeah, if you can't find it, it's in resources. Just download it and then we can upload it to our slicer. Is everyone good on this? I know I'm going a bit fast, so if you're having problems, just like raise your hand. No? Okay, cool. So we have our slicing environment. I'm gonna walk you through a couple of different settings. So on your right here, there's a couple of like very simple like things that you'll often find yourself changing often, right? So at the top is your print quality, or yeah, the layer height. So right now it's set to 0.2 millimeters. But basically it's just kind of like a general slicing profile that your printer will slice the part for, right? So in this case, it's going to be creating a new layer every 0.2 millimeters, and then it's printing on the quote-unquote quality profile. So it might print a little bit slower, but it'll be like have a better surface finish, basically. Underneath it is the filament type. So there's a bunch of different filaments out there or materials for you to 3D print. Right now it says ABS. I'm probably going to change that. But the filament is very important because they'll give you different material properties and stuff like that. You can get very rigid parts with certain materials, and then you can get very flexible parts with other materials, right? I'm going to talk more about different filaments next week, but you can print a wide range of stuff. So now, especially nowadays, when you have a like really high performance printer, you can print like carbon fiber infused filaments for like increased rigidity, or you can print like polycarbonate, which is like the same kind of material that they use for like bulletproof glass, which is kind of cool. But generally, we print with more basic materials like PLA, which is a like quote unquote recyclable. It's like not really, but technically it is. It's like a corn-based like bioplastic that is very common. I tend to use something called PETG quite often. If you ever bought like a disposable plastic water bottle, those are made of PET. So PETG is like very similar to that, but it's optimized for like 3D printing just to make it easier to print. But it's very similar. Another popular filament is ABS, which is what this printer is actually made of. I can talk about that more later. But ABS is a very common plastic in the injection molding scene. So if you have like Nerf blasters and stuff like that at home, or just like most kid plastic toys are usually made out of ABS. They're very like, they melt at a fairly high temperature, and they're pretty like resistant to most things, and it's cheap. But yeah, that's filament. That's like a really quick rundown on it. For my purpose, for the demo today, I'm just going to click on generic PLA. I don't know if that's an option for you guys. If it's not an option, you can go under here and click on add or remove filaments. And just like the printer profiles, there's a bunch of preset stuff that you can select from if it will load. But yeah, there's a bunch of different filaments. You can go in here and find generic PLA. It should be alphabetized, but yeah, I found it already, or mine's already in there. So I would just select generic PLA for now, because sometimes the print speed will vary. So yeah, please choose generic PLA. Yeah. For the printer, again, we have the original Prusa Mini. So yeah, just leave that as it is. We have an option to enable supports or not. So again, on the slides, like those are supports, right? So over here, you can like specify to the program if you want supports or not. In our case, I'm just going to say yes. I'm going to say everywhere, just to kind of show you what it looks like. For the 3D Benchy, it's not supposed to be printed with supports, but we're not printing it today, so I'm just like showing you how everything works. Over here is the infill, right? So how hollow your part is. Again, you can choose from a wide range, or you can enter it in manually. I forget what the rubric says. Okay, yeah. So if you're curious to see what I'm grading on for this assignment, you just follow all of these different profiles, right? So if you submit it in Prusa Slicer, you already get a point. I hope you've already selected your printer, right? we'll get to the perimeter count in a second. Resolution over here, so we can change that over here under the print settings. I think I said 0.15 millimeter speed, so I'm just going to press discard for now. So yeah, 0.15 millimeter speed for this assignment. I think supports are turned on, so I again set it to everywhere because I discarded it. Infill is set to 20%, so you can change your infill over here to 20%. And then it says perimeters are set to 3, right? So over here on the right, you can see that we can't change the number of perimeters, and that's just because we haven't opened all the print settings yet, right? So these are a bunch of like the basic settings, but if you want to fine tune your print, you can go under print settings, and it'll give you a bunch of other options, right? So over here under layers and perimeters, you can change the count. So right now it's specified as 2, but if I press this arrow right here, it'll increase it to 3. If you're wondering, I don't know if you've ever 3D printed before. Wait, raise your hand if you have 3D printed stuff before. Okay, awesome. So if you've ever 3D printed stuff, you might like find yourself wanting more options. So it'll probably open under like the simple tools, but if you want like finer control, you can click like advanced or expert, and then it gives you a bunch of other stuff. But you won't really go over that today because it's just like really random nitpicky things like how do you want the perimeters to be drawn or something like that, right? But yeah, generally the like 4 biggest things I change is the print like layer height, which is under print settings, like enabling supports, the infill, and then the number of perimeters, right? And then I guess material as a fifth one. But those are probably the ones that you're going to change the most. I find myself changing infill and perimeters the most. But if you ever start 3D printing yourself, you'll get into it and then you'll start to understand. But yeah, so now that we have all our settings in, we can import our model, right? So you can go under File, Import, like Import STL or 3MF, or you can press just Control I or Command I. If you go in the download, you find your model, it'll load it in, and then you should have like this green boat on your virtual print space, right? So this like gray flat area is a representation of your printer's bed, right? In our case, the Prusa Mini is like a 7-inch cube, so this is 7 inches wide, 7 inches tall, and yeah. But here we see our 3D printed, or our model right here. You can see if I zoom in, it's really nice and smooth. You can't really see anything, right? Or you don't really see any layer lines, and it's because we haven't sliced it yet. So if you see on the bottom right, there's this Slice Now button. If you click on it, your computer will do some thinking, and it'll generate a toolpath for your 3D printer, right? This toolpath is called G-code. So it's basically a really long set of instructions for your 3D printer to follow. What's kind of interesting is that 3D printers or just machines in general are like inherently stupid in quotation marks, right? It's the G-code that makes the printer smart. And well, that plus the firmware. But the G-code tells the printer what to do. So over here, now we see our sliced model. If I zoom in, you can see the different layer lines, right? On the right here, I can like drag this slider up and down to see the different layers. And this will give you kind of like a better understanding of how a 3D printer works, right? So I'm going to just drag this all the way to the bottom. I'm going to drag this slider all the way to the left. And you can see it's empty, right? But as I start to drag this arrow across, you can see this little arrow represents the nozzle, and the line that it is creating on your screen is the toolpath it's going to follow, right? So as I drag it across, you can see it's just creating like a 2D drawing of our print, right? So this is the bottom of the boat. It has some letters on the bottom, and then it fills them in, and that's the first layer, right? And then you'll see as I drag the slider on the right up, it will start to grow, right? You see the printers or the hull of the boat is getting taller and taller, and you can see the part growing by layer, right? So if you're ever curious on like how a 3D printer works, this slicer can show you the exact toolpath that the printer is going to follow, right? And again, it's going to continue to go up and up until you have your finished part. And it slices these according to all the settings that we placed beforehand, right? So we have the layer height. So because it's printing at 0.15 millimeters, it prints 580 individual layers, right? Again, if we change this, it will, okay, I'm going to transfer this. Okay, slice now. So I'm just showing this as like a demo, but if you change the print height, so I changed it to from 0.15 to 0.2, you can see that the layer count up here on the right, it's 277 now, right? So there's significantly less layers for the printer to print, but it will lose some definition, right? So like if you look at like the top of the little like cabin on the boat, you can see like the individual layer lines are stacking up, right? But if I print at a finer layer height, it'll look more like a slope. But yeah, again, these all kind of depend on your use case and what you're after. But knowing how to use the slicer is like very important because it's a very powerful tool. And you can either save yourself a lot of time or make yourself wait way too long for something that you didn't need. The other cool thing about this slicer is that it'll like tell you how much filament that you're going to use and how much time it'll take. So this is how I'm going to kind of grade you guys because it's kind of hard for me to, or I can't like go into your computer and look at all your settings, right? But if you did everything right, the amount of filament that you used and the time should be the same because we're all running the same profile. Or it's usually off by like 1 or 2 minutes just because some like rounding stuff. So if you did it right, I'm pretty sure your time should be close to mine. I'll let it slice. Okay, yeah. So your time should be about 2 hours and 50 minutes. If it's like 2 hours and 49 minutes, that's fine. That means you're close enough. I think like for some reasons the Macs round down and Windows rounds up. I don't know why. But yeah, if you followed everything, that should be your assignment. You should get full points. So feel free to take a screenshot now. Just make sure you have like the benchy in view, and I can see this whole sliced info down here on the bottom right. Yeah, what's up? So one thing to note, um, when you are using a slicer, if you slice the part and you decide that you want to make a change, you have to re-slice the model, right? So, like, if you would slice it at like 20% infill and you actually wanted it to be 15, you have to re-slice it because it has to recalculate the movement path. So, if you're not viewing like the slice info after a change, it probably just means that you need to slice it again. But yeah, does that make sense? Like, does the principle of 3D printing make sense? How it just like draws a bunch of lines. All right, cool. So what you would do once you're happy with your sliced product and you want to 3D print it, you would insert like a USB or SD card into your laptop, and then you would export it into that drive. You would take it out, you would take it to your printer, and then you would have it printed, right? For me, this printer is kind of nice, and I think a lot of newer printers are starting to do this. But this 3D printer can connect to Wi-Fi, right? So instead of sending like my sliced file um, to the printer with like a USB, I can like send it to my printer over Wi-Fi, which is kind of nice. Unfortunately, because of like Purdue Wi-Fi and stuff, it's like not working, so I have to do it manually. So I sliced a part already on this printer, and then I'm just gonna do a quick demo. Um, but yeah, so if you want to get up and like get closer to this machine, uh, I'll be doing a demo of how to use the 3D printer. Feel free to get up. Also, I forgot to complete. Feel free to come over. I'll see if I can fix this. Yeah. So this is my boron trident. It's a pretty cool 3D printer, in my opinion. It's a 4XY 3D printer, if any of you are familiar with that. Basically, it uses this like more complex. So it uses this more complex motion system developed by some like MIT guy. But the motion is controlled by these two motors in the back over the X and Y axis. And the advantage to it is the motors are fixed, so it reduces like the moving mass in the printer, allowing you to print faster. So this Crusoe Mini is like about this big. It was like my first 3D printer. also I recently finished this, so I hope it doesn't. But basically, this is a print bed. There's a bunch of different material that people use for print beds. In my case, this is like a textured spring steel sheet, so it's nice and flexible. The advantage to this is you can take it off and you can like bend the sheet and the parts will like really use themselves. You guys can see that in a bit. Another material that people use is glass, which is really flat. So a lot of people like glass. And then another material that's popular is E10, which is Aerolite. It's kind of what they use for printed circuit boards. It's like hard glass material. But yeah, this is the print bed. Mine is magnetic, so I can just yeah. Okay, so you're gonna just have to offer me. Uh, I haven't finished this. I finished it like the day ago. Also, if you want, you can pass this around. That's just part of what I made you. I wanted to. Um, let's see. Another cool thing about the Trident is that it has independent reactive motors, so it can actually trim the bed to be like perfectly flat. So you know how like we make a plane. So yeah, so like these are all independently controlled. So whenever I start to print, it will check for how flat it is and it will correct itself. Um, Another function that this printer has is automatic bed leveling. So if you like did a lot of 3D printing like a long time ago, that was like a really cool thing. That was like automated, so it's not super new. But basically what this printer has is has a little probe that picks up every time it prints, and then it will like probe multiple prints on the bed, it will trim it, and then it will also create a mesh of like the bed itself. So it will tell me like how flat the bed is, and then it will compensate for any deviation. This is a bunch of like nerdy stuff, which yeah. Um, like if you have any questions, you can ask. Um, so that is just a box. Yeah, it's just a dry box. Pretty simple. I do. So this is just like a box that holds the filament. So if you didn't know what filament looks like, it just looks like this. It's just a really long spool of filament, so plastic. Um, Most printers run 1.75 millimeter diameter, but some good ones. Um, And then I've been 3D printing for a while, so if any of this stuff is going over you guys, that's totally fine. Does anyone have any questions? I feel like it's better for me to much further. We're looking at over $1,000. Um, Again, it's probably not the best financial decision, especially because there's a bunch of new printers that are pretty cheap and very cheap. So one brand that comes to mind is Bamboo. If you know about 3D printing, Bamboo is kind of like a company that is disrupting the market. But they're printers that are pretty cheap for what you can get. They're pretty close to the standard service. I'm running a conservative cloud, but yeah, I wanted to go to one just because it's a fun project. So all these blue pieces and all these black pieces, you'll see around the 3D printer are 3D printed. So this is a 3D printer 3D printer. It's kind of cool. The Crucial Mini is also follows a similar like philosophy, called the philosophy. But the idea is that you can make a 3D I used my Mark III to print all the parts of my boron, and then I put it together. Um, but yeah, this is a fully enclosed printer, so it has like these little doors that keep all the heat in. So when we're printing higher temperature materials like ABS or like nylons or polycarbonate, you want an enclosed printer. So that's why I got it. Eventually, I hope this thing is going to be printing like engineering grade materials. So again, carbon fiber infused film is kind of what I'm going for. But yeah, again, most of the time, you just print like PLA or PCB. But I built this. I think this is just a 0.4 millimeter nickel plating nozzle. Yeah, I haven't like done any extensive mods to this yet. But it already has a couple of mods. So I'm just looking for this one. It has a foam cutter, so I'm gonna upgrade it later to be able to do multi-material printing. So there's a module that you can get for this that allows you to print multi-color material. I'm gonna make it print up to 8 colors. This is the homing process. It takes up the code. I moved it too much. Uh, in terms of like settings that I'm running right now, I guess I can open the slicer. So, like for reference, this Prusa Mini prints like a benchy with like the normal settings in about like an hour and a half, hour 45. This boron can print it in 45 minutes at like conservative speeds, right? So there's something called the speedboat race where people will try to make their printer print a benchy as fast as it can, and these things have been known to go like sub 5 minutes. So it's pretty awesome. The world record right now is like under 2 minutes, which is kind of insane. Oh, it looks like terrible, but yeah, but the idea is you just print it as fast as you can, and it kind of looks like a boat. So the speeds that the Mini is running, so it's running at like maximum like 50 millimeters for most stuff, 140 for infill, and for acceleration, it's like 800 to 1,000 millimeters per second squared. The boron right now is running like 300 millimeters per second movement speeds with like 5,000 millimeters per second acceleration. So that means it's accelerating at over half a G. So the tool has accelerated. Um, um, yeah, it's not unheard of for tridents to go over like 10,000 acceleration. So, this is like a modest actually work. Yeah, yours can. No, he got myself. Oh, yes, I believe that. Um, yeah, this is kind of sad. I did it twice. Now I want to do it. Yeah. I have other slides that I'm supposed to talk about. Do you tune your bolts to a certain pitch? I haven't done tuning to that degree yet. But my tool head has an accelerometer on it. So, um, yeah, yeah, the tool head can measure the resonant frequency of the machine, and then it'll compensate for that. Let's see. Did it restart? Okay. I'm just gonna blab about this while the printer works itself. Okay. Okay. So while it wakes itself up again, I was supposed to talk about this during the demo. Um, the 3D printer has some limitations, right? So, um, okay. Sorry guys, this is kind of annoying. But yeah, 3D printers have limitations, again, because we're limited to the laws of physics, especially gravity. So when you're designing things and you're designing things to be printed, you want to take into the account how the printer is going to move and what things that it can produce, right? So overhangs is something that a lot of 3D printer people talk about, and it's basically at, like the angle at which some kind of profile will kind of extend outwards from something else, right? So the more shallow the overhang, the more likely the printer is going to be able to reproduce it. A general good rule of thumb is just keep it at 45 degrees, just because, it's a nice even number between 0 and 90, so your parts will look nice and even. And I would say 90% of printers can kind of cope with a 45-degree overhang, right? Any more than that, the printer might struggle a little bit if you don't have proper cooling and stuff like that. Um, okay. So again, when you're designing things, make sure that they don't have overhangs of 45 degrees. So if you look at this benchy, oh, like this benchy is meant to be a torture test because it's supposed to be like hard to print. But you can see like the angle of this hull gets like progressively more shallow. So right here, this angle can be aggressive for some printers, and then you'll kind of start to see little artifacts, right? You'll see some drooping and stuff like that if your printer isn't tuned properly, or if your model isn't modeled as it should be. So like the hull on the benchy is a good place to see if your overhangs are too steep. Again, this mainly applies on like the vertical axis. So as long as your vertical parts aren't more than 45 degrees, you're usually chilling. Something to note is that holes or just vertical circles are actually overhangs. So for really small circles, it may not matter too much. But when you start making larger vertical circles, you might notice that the printer starts to droop a little bit, um, or the prints start to droop, and it's because like if you think about like the a tangent line around a circle, as you get closer to the top, um, it the angle of the tangent line approaches like 0 degrees, or it's just like completely flat, right? It's a 90-degree overhang for a printer, and when you print really large circles, the printer doesn't like that. So there's a bunch of ways you can combat this. My favorite method of fixing this is by creating a little teardrop on the top of the circle. So if you see on the right side, this circle has a teardrop on the top. I just create two lines like perpendicular to each other, and then just kind of cut away that section on top of the circle. And that ensures that the overhang doesn't go above 45 degrees, right? So, um, yeah. Does that make sense? The teardrop thing? So if you see some 3D printed parts, you might notice that some people put teardrops. They just kind of make me happy when I do that because I know that the prints kind of look a little bit nicer. But yeah, something to keep in mind if you're gonna 3D print a lot. Bridging is also something that you want to keep in mind when designing things. So if you have something really flat that spans across like some distance, that is called a bridge, right? And usually some short bridges are fine, right? So you see on the right. So if you see like on the bottom right here, the bridge isn't drooping that much, but as the bridge length increases, it will tend to droop. Again, because of gravity, it's going to be pulling the filament down if it doesn't cool fast enough, uh, and then they'll be drooping. Um, that can be fixed with some printer tuning, but not everyone tunes their printers to an insane degree. So if you want to make models that are more likely to be dimensionally accurate, you want to limit your bridging, right? Um, like an example of a bridge here on the benchy is like the top of this window here. It's just like a 90-degree overhang that the printer will try to reproduce. Again, short bridges are usually fine as long as they're straight, but you want to try to avoid having those. Again, you can't always like design out some of these problems, and when you can't, that's when you use supports. But in general, you want to avoid not using, or you want to avoid using supports. Um, I had a student in the past semester. I told everyone do not create long bridges, and then someone submitted a Golden Gate Bridge. So please don't do that because that is a literal bridge and a really long bridge for the printer to print. So needless to say, that print was not very good and it was kind of sad. So please don't make an actual bridge because I probably won't. Um, okay, cool. So another thing to keep in mind when 3D printing stuff is the thermal expansion and warping. So when you heat up a material, it will expand, right? So because of that, when you print things, the tolerances aren't exactly what you put in the CAD, right? So if I make a cylinder with like a 3 millimeter hole, the likelihood of it being exactly 3 millimeters is not super high, right? Especially with like a desktop 3D printer, the tolerances aren't super tight. Um, when you like work in a workshop with like mills and stuff like that, they'll be measuring things in like millionths of inches. So it's like fractions of human hairs. Um, a 3D printer isn't, or at least a desktop 3D printer isn't that precise, right? So generally, tolerances will range from about plus minus 0.02 to 0.04 millimeters. So I think that's like about the width of a hair. But for parts that interface between each other, that tolerance can be important. So you want to make sure you're keeping that in mind when designing things. So like for example, when I have like a hole that I want like an M3 screw to go through, I usually do it a little bit more than 3 millimeters, right? So an M3 is 3 millimeters, but I set the hole size to be anywhere from like 0.32 to like 0.34 millimeters, right? So increasing that gap will give the printer a little bit more leeway, and it'll help you assemble things better, right? You won't have to break out the drills and stuff like that. Um, you don't have to like take out a drill and post process. You know, I'm kind of lazy, so I would rather the part just work right off the edge, and post processing. So if you spend a little bit more time designing and thinking about how it's going to be made, then your part is more likely to work in the way that you want it to. The other thing to keep in mind is like elephant's foot on a 3D printer. So elephant's foot is basically the first couple layers being squished a little bit for bed adhesion, right? This is slightly less of a problem nowadays, but back in the day when we were just using like painter's tape and stuff like that to make things stick to our bed, elephant's foot was usually a problem, right? So if you look at this like circular image up here, you can see that the model is supposed to be like a nice line going all the way up, but the first two layers are a little bit longer than the other, right? And that's what elephants look like. So it'll swoosh out a little bit just so the print stays to the bed. Um, but if you wanted it to be perfectly flat on the edge, it's not always the case. Um, some ways to combat that are to add chamfers onto the edges. So what I usually do is I add a 45-degree chamfer onto the edge, so it'll cut the bottom diagonally. So the bottom's a little bit smaller than the wall. So if there's a little bit of elephant's foot, it'll swoosh out, but it'll still be like less than the wall, if that makes sense. So again, chamfers, right? Don't use a fillet on the bottom face because again, a fillet is a circle, and that circle will have a really tough overhang, right? And if you're using a tiny fillet, it may not matter, but if you're using a larger one, you'll kind of see that in your prints. So yeah, I tend to favor chamfers over fillets when I 3D print things. But again, it depends on your manufacturing process, right? When you're milling stuff, typically the tool is circular, right? So a lot of things will have fillets because the tool can't cut a perfect 90-degree pocket, right? So you'll have like a little bit of a radius from the tool. So, you know, think about how you're designing things. I don't know if that is making sense to you. Does that make sense? Okay. Yeah. So thermal expansion, again, it's not just elephant's foot. Sometimes it's the whole print. Again, if you like don't uh, properly tolerance your parts, it may not fit together. So like I was talking about the M3 screws. In this case, this was a final project from another past semester. This person created this really cool like Lego model. And then when we printed it, the torso didn't fit on the body, right? And it's because like in the CAD, everything fits, right? Because it's a virtual workspace. Like you don't have to worry about physics. Okay. But yeah, you can see how the torso on this Lego dude is not going together. So that's kind of disappointing, right? You don't want your parts to not fit the way you want. So making sure you properly dimension things and add a little bit of leeway in your 3D printing stuff is important. Yeah, so I don't know if you saw the rubric, but we have a quiz. But again, don't be alarmed. This quiz has like infinite attempts, and it's just kind of quizzing you on the various things that I've said today regarding 3D printing. Um, this is just mostly for you to learn. If I like miss something, this will tell you what I missed. Um, but yeah, if you want, you can take it now. Yeah. Does anybody have any other general questions? Again, I've been 3D printing for a while, so I can go into like detail about doing. Okay, yeah. So I was like, so it was like the strength question. So if I go back in the slide, I like highlighted it very briefly. But some things that you can do to increase the strength of your parts is one, is to increase the infill, right? Making your part more dense in the center will generally yield a stronger part. The other thing that will make your part stronger is by increasing the number of perimeters. I honestly go for increasing perimeters before the infill. That just makes the wall on the outside thicker, generally yielding a better part. Um, the last thing that people don't always think about is um, layer height. So layer height can actually affect the strength of your part because a lot of parts will fail on the layer, right? So every time you create a layer, you have a tiny weak spot where the part could shear and break, right? So if you decrease the number of layers by increasing the layer height, you'll generally get stronger strengths, right? The added benefit is like let's see. Yeah. So I just kind of gave you. But again, this class is for like your enrichment and not really like scoring really high scores. So as long as you're getting what I'm saying, then that's the most important. Also, I like to talk a lot. So if you don't get everything right away, that is also totally fine. Um, I guess another thing that I didn't really mention in the slides that's just something to note. I mean, I'm not going to quiz you on this, but print orientation, right? So when you design things, um, you're going to be designing them to be printed in a certain way. And if you have the geometry of your part in an unideal way, then your part is more likely to break. Right? And this goes back to the layer lines. Right? So the layer lines are weak points on 3D printed parts. And that's why generally 3D printed parts aren't as strong as like their injection molded counterparts because it's all one solid piece instead of tiny layers. So if you create a part and it's printed in the wrong direction, then it will snap, right? I guess I'll like CAD something up real quick. mounting holes, for example. So that can be an important place for strength and stuff like that. And if your prints aren't oriented correctly, then your strength will suffer. Okay. So I'm just going to create a quick sketch right here, and I just create a very random, messy part. Okay, I'm not fully constraining this just because it's a quick. Okay, cool. Oh yeah, this is also a good reference for if you want your project to be printed. I forgot to mention that, but when you go to export your files onto Fusion to have them 3D printed, there's a couple of file formats that you want to use. So if you go under File Export, I'm pretty sure, it'll ask you for the type. The slicer program can't read a Fusion 360 file. It usually reads STLs and step files. STLs were really popular back in the day, but steps are kind of taking over just because they can they have a little bit more precision. Basically, what an STL does is it takes your model and it sections it up into a bunch of little triangles, and then it exports like a mesh, right? A step file can retain arcs and stuff like that. So generally, that file type is preferred now. But yeah, anyways, under file type, you can choose STL or step. You kind of have to scroll down at the bottom. Yeah, that's fine. And then, okay, I didn't save this. Crap. Okay. So I'm just going to export it as a step. And then I'm just going to put it in my downloads folder. But yeah, when you submit your final projects to be 3D printed, this is how you do it. But yeah, make sure it's a step or an STL. Either or works. Okay. So, well, okay, that's kind of big. So let's say I printed this part in this orientation, right? I printed it vertically, so the layer lines are oriented vertically, right? Depending on your use case, right, this could break along the layer line, especially for a hole like this. If I was to twist the part and torque it kind of outwards, it would probably snap along this layer line, right? So it would break in half, and then it would break like this, and then you'll be sad because your part didn't work, right? And sometimes it's not the geometry of the part, it's how you sliced it and printed it, right? Now, if we change the orientation by placing it on its bottom, right? If we slice it, you can see how the layer lines are oriented in a different direction, right? And then in this case, for it to shear all the way, it'll have to pull the whole layer and break it in half, right? So again, depending on your use case, uh, orientation can matter. Um, yeah, you'll kind of understand if you start 3D printing stuff more. Um, you'll just kind of get a feel for what works and what doesn't. Um, but yeah, make sure you orient your parts the way you want them. Okay, it's actually working now. What a surprise. But yeah, if you want to watch the printer go, it's kind of fascinating. I brought a printer to my grandma's house once, and she like watched it for 2 hours. So I thought that was pretty funny. So yeah, it's kind of mesmerizing just to watch the print go. Yeah, I have like 5 3D printers at my house right now, and they just kind of go all the time. So it's kind of fun. It's like a little mini factory making different parts. Um, yeah. If you ever need things 3D printed, there's a bunch of clubs on campus that do it. I don't know what their regulations are for like volume and stuff like that. But if your parts are too big, I'm happy to 3D print them for you. I printed a bunch of random things for some of my students and my friends. So I know like some people make like carbon fiber molds for like rocket parts, and then they asked me to print it because my printer is really big. So that's one thing that I do. Um, but yeah, again, the limitations of 3D printing are like kind of unknown at this point. You can make a bunch of things. I made a battle bot out of like 90% 3D printed parts and it didn't break. So if you design it well, like 3D printed plastic parts can hold up. Um, but yeah, I don't know. Do you have any questions? Um, yeah. Oh, yeah. So down here in the bottom left, there's like the slice preview and the the editor view. So if you're in your editor view, you can click on your part and then you can do place on face, and then it'll highlight a bunch of edges. You can also like use the move tool or the rotate tool to rotate your part in the way you want it. I just press F because it's easy, and then like I just click on the face. Um, Another thing that you might want to do is like paint on supports. So like the slicer will allow you to specify where you want supports to be generated. So like if I wanted it printed in this orientation and I didn't like want it to do supports automatically, I can specify it manually. So if you have a very complex part, then you can like make sure that it specifies it for some things and like excludes it for others. Like for the smaller holes, they're technically overhangs, so the automatic overhang detection will create a support there. But then like if the hole is like just tiny and it creates a support, then it'll just like fill in that hole. So it's not perfect, like the auto generation. So you can do it manually if that's desired. But yeah. That's basically it for today. So if you want to go, you totally can. I'm probably going to stick around here and then cram for thermo. But yeah. Also, if you wanted to, two of you can take these sample prints and take this one as picture if you so desire. If not, feel free to send your file to me.